Yo. Alright, turn this down some. And now we can figure this out. I don't know why my music is so loud. There we go. It's probably better. Alright, y'all, what's going on? I'll cut my audio up a little bit. We are doing things. once I started getting into like, this is intriguingly hard and yet fun, and also I should be streaming this now. This is kind of how we got here. So let's start with where we are really quick, and then I'm going to drag this over really quick. So we'll start at the beginning. I have this thing for the podcast that I do called Conduit, where we do transcriptions, and I upload those transcriptions into OpenSearch, and then I can use my Fast API app to basically create like a RAG application that gives me productivity advice based on my own transcripts. So in doing that, one of the steps that I do regularly is I will open up Mac Whisper, which is apparently needs an update. That's fun. Again, I will open up Mac Whisper, which is this thing. Yeah, we'll update it. Go ahead. Why not? Cool. And then I do the thing where I put in the URL. Well, technically I just drop the audio file into Mac Whisper and do the thing, which was cool. It would give me the transcription. Please don't do that again. I don't need that. Anyway, it would do the transcription, and then it would give it back to me, and then I would chunk it, embed it, and put it in OpenSearch, all that stuff. So there were a couple of things that I would want to do in that. One, if I don't have to do it, that's great, because then I can just have GitHub do it for me. We release episodes around the same time all the time, so I could just have it run the next morning for me, and then boom, automatic transcription, automatic updates. I can do things like check to make sure that my services are still running. All that stuff happens without my intervention. So in order to do that, I need to figure out, well, how do I use the Whisper model just in Python and not in some GUI? And that's where I'm at now, is that I'm trying to figure out how to use that interface. I'm trying to turn this down some because it is really loud. That music is just so darn loud. Anyway, so to make that work is the challenge. I'm going to walk through what I've done so far. We don't need this anymore because this got removed. All right, so step one is download the audio file. Right now we are hard coding how to download the audio file. I will tell you, we already have how to do that here. If I go to CD, Conduit, file downloader, URL finder.py, we already have a way of doing that. It's right there. And that's just using, Gazpacho, which is a web scraper, to scrape the website and get the audio path from the file. Relatively easy. We can do that quickly. Honestly, if we want, we'll copy this from here. So now the reason I haven't done this is because I was thinking if I wanted to reuse this, I want to be able to pull the audio from anywhere. So like, let's just copy this into, let's just do this. We'll do CP, URL finder, and then we'll do, boom, boom. So now we got URL finder in here, which is great. So I can now just type in, Python URL finder, and we'll say conduit episode 80, right? Ooh. There we go. So that gives me the audio path. So if I really, really just wanted that, just like that, the answer would be I could just do the command to do the transcription, Python or it's like tools, transcribe, and then the path would just be the path. So it would be Python URL finder 80, and then conduit 80.txt, right? Something to that effect. Now, all right, so then it does its thing. And now it's just reading the audio file, processing it. And again, it's like a 45-minute file, so it takes some time. And I'm okay with the amount of time that it takes. Like, it doesn't need to be the fastest thing on the planet, especially if I'm not the one doing it, if it's just running in the background. But that worked. So we didn't have to do any magic here. We were just like, I want you to take this transcript, I want you to do a bunch of stuff with it, and then throw it into this other thing. Now, this is probably going to throw a fit at some point, because I think I forgot to save some stuff, which is fine. So what that did was this downloaded the file into a temporary path. The temporary path gets deleted when I reset my computer or whatever, so it's like no big deal. I'm trying to figure out if there's a better way to do this in the terms of the temporary path, because what I've noticed is it deletes itself once it's done. I just don't know how to get that to not delete itself when it's done, because this works clearly. So from there, it loads the Whisper model. Then it does its little transcription. What I've learned, and I had verbose mode on so that it was actually like outputting the stuff. I don't know if it's faster or slower with or without it, so I have it turned off. I can turn it back on if I wanted to. No big deal. The next step here, we're going to ignore clean text for now, because clean text is doing some goofy stuff. All right, so then we do transcribe from URL, which just combines those two things. So it actually we don't run this at all anymore, mostly because I couldn't figure out how to make it work. The answer was follow redirects, because apparently our podcast link is redirecting to another thing. So we're going to follow the redirects, then we run the response. I don't know if we have to seek the audio or not, so I might try turning that off soon. Once that's done, we take that result, then we take the text of that result, and then we split it into using LangChain's recursive character text splitter. And what that does is that puts it into chunks of about 300 characters or 300 words or so and splits them up. We could probably actually reduce that to about 140. I think it would take longer to do the embeddings, but the embeddings would probably be a little bit more accurate. I did 300 because 300 is what I'm currently doing for the application. So I was like, that makes it easier. Honestly, if we get to a point where like everything is embedded or everything is chunked beforehand, I'm currently doing this twice. It'd be great if I only did it once. That would be really cool. This is almost done. It says 20 seconds left. But all of that's going to output into a file. That output file currently looks like this, roughly. And as you can see, there's text of different amounts. And And some of that's based on just like it's trying its best to do equal splits of text. It's not really using context to split them. But that's the thing that I'm trying to fix now. All right, it's done. Boom. From Relay FM, you're listening to Conwood. Cool. So like it's doing the thing, right? So, and then now we have a transcription, which is cool. Like this alone would be enough to make me happy. However, I want more. Like I said, the thing that I've been wanting to do with these transcripts, as you can see, I have plenty of these. We also have this issue of taking the front matter and putting the front matter in there. That's a thing that we will do. We will continue to do just because we have to. That's why I haven't added this yet. Why is there an empty line here? That's weird. Oh, yeah. No. That's special guest, baby. Okay, that's all one thing. That's not. I was like, wait, what? What's happening? But that URL is all there. That's all one phrase. But yeah, as you can see here, the transcriptions are doing things, but it's doing like the same thing. Some lines are longer, some are not. It's doing recursive splitting based on ideas. So that's when I was trying to figure out the big solution of, can you actually chunk objects based on paragraphs? And the answer I found here is a little bit more advanced than what I'm used to, but I think I can follow along with it. They said with a lot of confidence. False confidence, I guess. I'm trying to see is things running. Tap. Is this thing on? Oh, sorry. Tap. Punch your mic, I guess. Simon says punch your mic. Okay, yeah. Sweet. All right, so what we want to do is we don't want to just copy this. We want to understand how it works and then use that to... We want to understand how this works and then use that to basically take sentences, see how similar the sentences are to the previous sentence, and then convert them into paragraphs. And the way that this, this person, Mr. Polovkin, is doing things here is, and see, they're using it for podcast summarization too, which is interesting. Interesting. I just think that's cool. Came from one podcast idea to another podcast idea. So their approach is they're using natural language processing to create a vector, which is fine. Used to that. Same thing that we're doing in here. Not there. You don't want to see that. The same thing that we're doing here in OS ingest. We're using a recursive text splitter, which again, like I said, I think a lot of this is actually just going to go into quote unquote paragraph. And then paragraph is going to be the thing that we do from now on. And then using a Hugging Face embedding, we're going to generate embeddings. And it's just using the all MPNet base v2 embedding, which is kind of the standard for this kind of stuff. And then we're gonna take these things. Let's just copy these, right? We're gonna put them in paragraph. right? We're going to take those. I just realized I probably should have named this using AI and Python, not just using AI. But it's fine. Not the end of the world. So anyway, so we've got this. We generate the string. So in terms of generating the paragraphs, sure, we're going to do that. But we're not, trust me, we are absolutely not just going to let Copilot tell us what to do on this. It gets hairy really quick. So step one is we take our embeddings, we take our string of embeddings, necessary packages, pandas, numpy, sentence transformer, sklearn, seaborn. I don't think we're not gonna need. We don't need these. We do need scipy, which there's a little concern here. I'm not as familiar on the scipy thing. We're going to start with the parts that we do know, which are just we're going to take our sentence transformers, we're going to split them, and then we're going to generate embeddings for those objects. So we've kind of already done that in some ways over here. So let's take stream from splitter, split text, boom, right there. And then we go to paragraph. Text is going to be, so text is a flat string. And we want to take I'm going to do that with it, right? And then we want to generate embeddings off of that split. So that would be, let's see, embeddings. We're not embedding documents. It's embeddings. Come on. Oh, I don't have Hugging Face embeddings imported, so it doesn't know how to do that. What was it? From langchain.huggingface embeddings, import Hugging Face embeddings. There we go. And then from langchain text splitters, import. Perfect. So now we can take the embeddings, go down here, come back. Encode. They're saying encode. Okay. So yeah, when you do sentences, they're doing their sentences on that split right there, which is fine. Oh, actually, this is interesting. So interesting enough, one of the things that we picked up as like a bug in this is it's fixed here because we fixed it, and it's fixed here because we fixed it. But these punctuation marks are the splitter, and those punctuations always started on the second, on the back end of the split. And I don't want to play around with text character splitter that much to like fix that. So what we did was we took inside of transcribe, we took this clean text here, and it's just doing some very functional work in that it is taking, we did add it here. it's taking the list of texts that are there and it's swapping their place. It's taking the punctuation and basically putting the punctuation on the index before it. And that's one of those things that like I just got to think about with this, because we do split text and then we clean the text. The clean text basically, no, we can't do clean text. Let's call it fixed punctuation or something like that. Like that. So now our clean text list is fixed punctuation of split text, which we could probably also just do fixed punctuation of splitter split texts. I mean, that would do the same thing. Fixed punctuation of splitter split text. Cool, now we got split text right there. Embeddings of split text is great. So that fixes that. Now, so that generates the embeddings. The next thing that they did here, which I mean, again, don't worry about that, is they get the dot product. And basically looks at two embeddings and says, what's the dot product of, like, what's the difference in these items? And this is what I'm trying to figure out what they're doing here. Dot product is second sentence at third. What is second sentence at third sentence? I'm trying to see what they're doing here with this. So let's see. First sentence embeddings 0:1. Let's create a little test. Well, we can just call paragraph, right? We give it 2 sentences and then we do generate paragraphs. Let's do this. Generate embeddings. Sure. We don't need to do all that stuff. That's just doing the same thing. We don't want to do that. We just want to do a list of text like that. And then we just do something to that effect. I kind of just want to see what happens, because what they did was they just did what is that @ sign? This is like some Python stuff that like I rarely do just because I'm not dealing with a lot of numbers. We do one at 4 unsupported operand types for that. Okay, so what does that do in Python? We're gonna learn today. in the middle of a line, and at in the middle of a line is a probably matrix multiplication. So as a binary operator. You think it's just an example comment? Oh, what's up, Jeff? I was actually trying to see. I saw your note saying that you weren't doing your co-working. I was actually going to join y'all in co-working, and then when you were not doing it, I was like, well, we'll do something else. It's just an example comment. Well, the reason I wasn't sure was this is an F string. So I was like, that can't be a comment because that F string is doing something. But yeah, apparently, I guess if you have two matrices, you can do multiplication on them. Unless it really is a matrix. If you print A at B, this code yields math. It yields math things. Families in town. Oh, very cool. So yeah. So basically they're taking. So wait. In their example, they have second and third sentence. Okay, so 0 to select row and all columns. Okay. Row 1, all the columns of row 1. Is what I'm seeing? Is that what I'm seeing? And then they're doing the multiplication of the embeddings of that row and all of its columns compared to the other. So we'll do here from, well, I'm not in tools, am I? Oh yeah, I do have access to tools. From tools.paragraph. Import embeddings. Nope. My keyboard literally just like went to another screen. Yep. Feel like it's gonna do the. Yep, I was gonna say it's got to do the download of stuff, and then we can do generate embeddings, and we'll say Jay is cool, Jeff is cool. Expected string or byte like object and got. Hold on. Oh, a collection of string constants. So encode doesn't work like that. Encode's not doing what we thought it was doing. Why is this also? I'm still confused as to why this is not. I probably also shouldn't keep calling this embeddings over and over again. There we go. Here we go. So embed documents, embed query. Yeah, I'm very used to the embed documents. And the documents are just the two separate strings. And then that's where we'd go text list like that. And then okay, wait. It's still trying to split this. Why are you still trying to split this? Did I call something? Well, that's wrong. It should be a string. Again, I don't think that's the problem here, but yeah, that's what I thought. And split text, self-split text separators. What's confusing to me is that in this embed document, it is trying to split the text again. And I don't know why it's trying to split the text again. It shouldn't. Compute doc embeddings using Hugging Face Transform Model. A list of text to embed, output. List of embeddings, one for each text. Yeah. There we go. Apparently, it was choking on itself. All right, generate embeddings. List indices must be integers or slices. Okay, that's fine. So this is, it just needs to do this. Not a tuple. What? Okay, well, let's do this first. So that generates the embedding, right? Let's do this. We'll say because our return date was to 0. That's why. So it only gave me the first embedding. Okay, so if we say a 0 what was it? What did they say? Embeddings at index 0. Because here embeddings is all of them, right? Yep, split text into sentences. Model encode, encode. What is that encode? I don't know what encode is. I see encode quarks. I don't see encode anymore. I don't think encode is there. I wonder if this is a thing that's in sentence transformers. It's not in, yeah, it's in sentence transformer. It's not in LangChain's version, which is fine. We can work around that. Oh, wait. All right. I think that there is a... Okay, there we go. So now if we do length of A, we should have 2, right? Each of those is 768. If we do A 0 colon... Okay. The challenge here is that I think we don't need to do that part. I think if we do A0 at B, or sorry, at A1, list and list. Okay. The text reminder of this. Okay, so we did second sentence and the third sentence. Second sentence, third sentence is embeddings of 1. So I wonder if, because we're returning a list of the documents, I wonder if it's just not in a format that is compatible. Is that the problem? Encode quarks, A embed, async embed from ORM, parse file, parse object, parse raw, show progress. So encode passes what? A NumPy array? All right. So it seems like it's because I'm using the LangChain version of this. So LangChain encode to NumPy. All right, so model name is this, model quarks, encode quarks are that. Multiprocess, show progress. Oh, those are parameters that we have. Whoa, what? LangChain. Oh, this LangChain can be, yeah. It's deprecated, but like Hugging Face is now, it's in its own space now. That's all it is. This is interesting. So the problem is that it's doing more than what we need it to, which is frustrating, but you know, LangChain. And my question is there a way that we can, and the only reason I'm so set on using it this way is that I'm already using it this way somewhere else. So if I have to I would much rather like go do a different thing or not have to do a different thing. Datasets, tools. All right, well, we can just use sentence transformers, I guess. The way that they're using it, you just use sentence and transformer, and then you just use encode. Okay, I mean, that's not the end of the world. In that case, we get rid of all of this. We paste that in. And now we just say model encode this text list. Oh, I didn't import sentence transformers. That's on me. I was like, that actually might still work, because I'm pretty sure that, yeah, lane chain hugging face would import it somewhere. Shouldn't work, but okay, that's what I thought. Okay. No. Okay. So now we actually have an array. Like we actually have like a NumPy array, which means that now when we do, this would have to be boom, everything, boom, everything, and we get that. All right, so that's doing what we want it to now. So it's taking these items, and it could compare, you know, if we did a bunch of these, it would compare them. And then what they're saying is to do cosine. What is a cosine similarity matrix? Interesting. So they're saying that when they're all the same length, there's no difference between the two. Interesting. I mean, I kind of wish you would have just told me that. I mean, you did. I just didn't read ahead. So cosine similarities are scikit-learn. Okay. Interesting. We definitely don't have scikit-learn in here, so that's a thing we add. I don't even remember what is that? What is it? Yeah, let's make sure this is like scikit-learn. This. Scikit-learn, like that. And now instead of doing this here, we'll do embeddings. And they were saying you just do that across the board. So from scikit-learn metrics pairwise, do cosine similarity. And that's how we pull that in. I don't even need to plot it. I just kind of want to see what they are. So similarities are the cosine similarities of the embeddings. So now if we do the cosine similarity of those embeddings, we're not doing any reshaping. We're just doing cosine similarities, embeddings, similarities. Cool. So now, let's just do this. Sure. No. Generate embeddings is going to be a list of text. I don't think we got to do that just yet. So generate embeddings is, let's just do a string. Oh, let's just generate the paragraphs. Just do what we're doing. We can bring this back in. And then now we're going to generate embeddings. And then that's going to be, yep, that's just text. We can just bat a file and then do that. That'll work fine. Yep. Split text, fixed punctuation. Yep, that's cool. And then generate embeddings of the split text. Cool. Oh, well, I guess, yeah, I don't have typer running in here, so just print that. Why not? We'll just do conduit 80. It's going to generate all those embeddings, doing the thing. It did not print anything. Something act up. I more just want to see this run. Okay, yeah, I'm doing something wrong. Oh, I didn't save it. Duh. And this is where we say Dodoy and we just go about our business. Oh, because we did generate embeddings. We didn't do generate paragraphs. Whoa. Huh. Something's not right. It returns a list of strings, right? Yeah. Fixed punctuation. Returns a string. Ah. So yeah, there's only one. I was like, that's wild. All right, so currently fixed punctuation joins everything back. How? No, it doesn't. Returns a list. Yeah. So returning a list. We're returning a list, and this wants a list, right? Generate embeddings takes a list of strings. Thank you for the thumbs up there. Model encode is doing a thing. Can we maybe we just print out the length of the embeddings just to see what's going on there? Yeah, it's only showing one thing. So now the question that I have is, okay, so that's what it is. Our splitter is not splitting things. Split text into multiple documents. It's not reading the text. It's just taking the file name. Wah wah. I'm funny enough, I'm kind of not using an LLM yet. But further in, for none of this, I'm using an LLM. But I'm using Hugging Face's sentence transformer model that they use, the all MPNet base V2 model, which is kind of a standard one with this. In the actual Fast API application that I have for this, I just use Olama because I'm testing it locally. But everything is being done with a lot of help from LangChain, so that if I did want to replace it with production models, I could. Yeah. I feel like a simpleton right now in what I just did, because I told it, right, generate paragraphs, text. That's not. File name, pathlib.path. Import pathlib. That was the womp of that was supposed to be a path. This text file name read text. We do this, same thing. We probably get a lot more. It probably takes a lot longer to run. 33. There we go. That's a good number. A bunch of different models. And now we have an array of cosine similarities, which is cool. And then they were saying you can do, let's see, python-m pip install matplotlib. And they were plotting there, so they were just doing a heat map using. Don't tell me they're not using like SNS for the Seaborn. I'm not smart enough to know how Seaborn works. Seaborn is so much more than what I'm familiar with. Now we're getting out of my realm. This is where I need like Aaron to help me. Actually, hold on. That might actually be arrangeable. Might not be available. All right, so this is just so that they can visualize the... I want to see what these look like myself. Because if it looks like that, that's kind of cool, actually. I don't know if it will, though, or not. Oh, no, those were just the embeddings. Those weren't the similarities. We didn't plot the similarities. Okay. Import Seaborn as SNS. Good luck with the firewall. Matplotlib is building the font cache. The Seaborn is using Matplotlib for that. Doing its thing, generating the embeddings. Is there a view of this heat map somewhere? Can we just return that? Like that? Does that work? Can we just print a Seaborn plot? So yeah, the length of split text, we don't want that. That wasn't what I was expecting, but let's see. Visualize Seaborn plot. Show. You may need to explicitly call matplotlib plot.show. Okay. So that's what we were missing. Okay. SNS pair plot. I just wasn't sure if I needed to do a thing here. There, ooh. That's a lot of values. That's a whole lot of values there. Sure. But the pattern looks relatively similar, which is interesting. It's kind of cool how it does that. The red square in the middle part is where I talk about football. Football talk, I guess. Okay, cool. You can see two different topics and their split points, identifying split points. Okay, so apparently the way that this works is by doing this is a 10-minute transcription plot. Is what we're gonna see is the plot of 10 minutes. Do we see squares? I don't know if I see squares though. I see like some blocks, but I don't see like squares. And this may be due to them. They're talking about this working with long text. When you work with long text, you'll have the problem that very short sentences create unexpected changing points. The shorter the sentence, the lower similarity is possible. The shorter the text, the less information it contains, fewer possible similarities can be found. They're to deal with this, but the way that they do it is most simple. They'll shorten very long sentences and reduce very short ones. Okay, so that's for big text. It's hard to distinguish an array shape. So that's a bad one. And then they talk about splitting these into local minimas. A local minima is identifying split points. Now, when something is easy to see for humans, but not necessarily easy for computers. Sure. Take each diagonal. So find the relative minima of a vector. And this is where it gets gnarly because I have no clue what any of this means. This is me outside of my element, but we're going to try to figure it out. The combination of relative maxima and minima is called the relative extrema. I remember something like that from statistics. The rev sigmoid. Okay, well, yeah. We'll take the rev sigmoid of an item. We'll activate similarities. So a part of me really just wants to like copy and paste this, mostly because I'm just like, what does this even mean? But I'm definitely going to say copied from because I have no these are all like NumPy things. Yeah. It creates a weight for the sigmoid function. We have to create a space. P size will determine the number of sentences used and the size weights of the vector. Then we vectorize it. Because we only apply activation to p-size number of sentences, we have to add zeros to neglect the effect of every additional sentence to match the length of vector we will multiply. Then we take each diagonal to the right of the main diagonal. Okay. Pad each diagonal by zeros at the end. Because each diagonal is a different length, we should pad it with zeros at the end. Okay. Stack those diagonals into a new matrix. Apply the activation weights. Ooh, my brain. Am I machine learning? Am I learning about the machines? Okay, so now they activate their similarities with a p size of 5. P size is what, the size of the sentence? number of sentences we're using to calculate the weighted sum. Okay. Return activated similarities. So if we generate our embeddings, we have, so we're going to come here, we're going to say embeddings are equal to generate embeddings of these. And then we're going to say similarities is equal to activated similarities of our embeddings. Whoa, similarities are... What are the similarities in this, though? A square matrix where each sentence... Okay, yeah, corresponds to 1. So those are our generated embeddings right there. Embeddings, and then we just give it a p size, and they said a p size of either... We'll do 10. Why not? We'll do 10. Sure, cool. We'll see what 10 does. Let's create an empty fig for our plot, or empty figure for our plot, and then find the relative maxima and minimas of each of these. So basically now they're just plotting these. They're just plotting this. Okay, so we're gonna just copy this. Oh, did I get rid of the show? I did not. Darn it. So I feel like with this, we gotta change this to return similarities, right? Yeah, return similarities. Something didn't get saved. It didn't get saved. What are these imports? We're definitely missing some imports here. Oh, from SciPy signal import. Okay, cool. Oh, similarities isn't accessed here. All right, so what's happening here? What are we looking at here? All right. Activate similarities is like this whole nother function. Activated similarities are here, then you return the activated similarities. So why is this choking? Oh. Yeah. Activated similarities are like right there. do math. Mm-hmm. Okay, and then this is where we have a plot, and we got to do plot show, because otherwise we're not going to see it. Okay, here we go. Ooh, oh snap! Look at that! Look at that! So it was able to basically take those peaks, find the relative minimas, and then like turn those into different paragraphs. Well, it hasn't done that part yet, but it's done the hard part. So now you have to take split points. So for each of those minimas, create an empty string for each and enumerate sentences. Check if sentence is a minima. Then add a new line to the end. So again, we don't necessarily need to do the plots here. That's just showing them. So again, we don't need these. We do need minimas. All right, so then we say split points are and they're doing this in split text. So then we would just say there is a part of me that does want to understand how active similarities work, or activated similarities, but it has like weights, and it's like looking at the shapes between them and looking for differences in the weights. Like I get what it's doing, I just don't get how to display that in NumPy mathematics stuff. And that's where I would really love it if a data scientist came in and like explained that part to me. All right, so in each line, again, they're doing an empty string, which is kind of weird. But I kind of get it. It's probably the easiest way to do it. Text is empty string, right? And then you do right? And then you just say if yeah, like that. All right. Okay. All right, so it got a little It did the thing. It didn't do it great, but it did do the thing. And I think this could be because of the P size. I wonder if we reduce the P size, then if that fixes it. Now, I wonder if the P size needs to be larger or smaller. We did a smaller P size. What if we do a larger P size? $20. I'm mostly just trying to figure out what's the interesting. P size is 10 here. I'm mostly just intrigued in like, can we futz around with this a little bit just to get like a better expression? Where's that rev sigmoid thing at? Rev sigmoid right here. Vectorize rev sigmoid by x. X is what we pass in. Okay. As Bobby Hill would say, okay. That's interesting. But that's like 80% of the way there. All right, so now we've got paragraphs. I do want to do this on 80 just because I feel like 80 is going to be... All right, let's do two things. One, we're not going to print the text. We're going to just output the text to an output path. So we're going to say file name, output path. Yep. We'll say cdt 80.txt. Boom. Okay, so there's cd.txt right there. Bam. I mean, that's kind of cool from relay F. Oh, you're listening to the conduit. So this is like one of those things where like this would be better. Huh. Uh-huh. So I'm learning something. I'm learning something that I both like and don't like. It worked. it worked and it's not helpful. Like it did what it was supposed to do. It looked for similar sentences and then separated them when things changed. And yeah, that's what we were doing. We knew it wasn't going to be perfect, but we thought it would be good enough. The challenge here is we're probably better off just doing speaker diarization. And speaker diarization is one of those things that is very, very complicated that my brain struggles to comprehend. Mm-hmm. Hmm. So this is interesting in what it's trying to do. Because it's doing two different things. It's trying to do like this to this. This is what I was trying to figure out. We'll use Whisper to transcribe the different segments of the audio file. Important, there is a version conflict with... Okay. Running over prepare audio file. It writes transcription into a file. You can adjust the model size to your needs. You can find all models. Yeah, it's fine. So these are VTT files. Is that what it's telling me? Is that Whisper does... Oh, good Lord. More of what I'm trying to do is I'm just trying to see if I can have it determine who's speaking where. Because my thought is if I could say diarization.txt read split lines. Split lines is just going to give you a bunch of segments, right? Let's see if we can learn about Pionode audio. Which is like Pyannotate, I'm guessing. Pip install Piano. Okay. Oh, you got to use... Yeah, see, this is what I'm trying to figure out here. For turn underscore speaker indiarization iter tracks yield label. Pre-trained pipeline, state of the art. All right, so if we're doing this, I was trying to see if I could find like a basic one. Not seeing one. All right, so all right. So we did all that work ultimately for nothing, but it was a great little test run on what we wanted to do. Unfortunately, it's not helpful. It's not helpful. Like it just really isn't. We are better off just splitting the text using a recursive text splitter. Boom, like that. And then what we can wind up doing here is we had URL finder. I think what we want to do is we want to find more in that, but that's going to be for another time. I'm going to head out. This has been fun, but I love exploration, stuff like this where we try a bunch of stuff and it doesn't, even though it didn't work, hey, we tried it and now we can at least say, hey, we tried this and it didn't work and here's why. So if you liked it, subscribe, all those fun things, and I will see you later.